Okay, for the guided practice problems, we are going to be asked to find the probability if you randomly choose a point within the larger region, what is the probability of it landing within a shaded region? So, guarantee that you choose a point within the larger region, and if you randomly choose a point, what is the chance it actually lands in the shaded region? Okay, so here we go with the smaller regions. We're going to do the area of the smaller region divided by the area of the larger region. So 5 times 4 is 20, and 8 times 15 is 120. And then we can go ahead and reduce that down. But for this particular problem, it doesn't tell us we have to put the final answer in reduced form. It actually asks us to write it as a percentage and round to the nearest tenth of a percent. So 1.7 is going to be the rounded answer. Sorry, 16.7%. My fault, 16.7. Shh. Thanks, guys. Okay. So now this next problem has the outside shaded. So if you remember, we're going to do large, subtract small region, divided by large region. So the large region is 10 times 11, and 10 times 11 is 110. Subtract the small region. And these lines represent that this is a square, that each one of these sides is 5. So 5 times 5 is 25. And divided by the large region, which is 110. 110 subtract 25 is 85. And take 85 and divide it by 110. And we're going to round to the nearest tenth of a percent. So you're moving the decimal 2 places to the right. And then looking to see, do we round up or stay the same? So 77 point, it's not going to be 0.2. This says we round up 77.3%. Okay, third one. Again, we have the outside shaded. So the large region is going to be 12 times 10. 12 times 10 is 120. Subtract the small region. 10 times 8 is 80. Divided by the large, which is 120. You can't just, a lot of students in previous hours are wanting to just cancel out the 120 on top, the 120 on bottom. Not mathematically correct. First you have to do the math on top. So 120 subtract 80 gives us an answer of 40. And now we're going to take 40 divided by 120. And 40 divided by 120, a lot of you are just able to do that in your mind. But that's 1/3 or 33.3%. Down to number 4, we have the smaller portion now shaded like example 1 or example 1 and 3 that Sergio and Diego went over in class. Again, this represents that all sides of this inside region are the same length, and they are a length of 4 units. So, area of the inside is 16, area of the outside is 40. 16 divided by 40 is 0.4 or 40%. Remember, you're moving the decimal 2 places to the right. Again, we have your shaded region on the inside. So inside region has an area of 10, outside region has an area of 40. When you divide, you end up with 25%. Moving on to circles and semicircles. Inside is shaded, so we're going to do the area of the inside. So we're working with circles, pi r squared. So the radius is 1. 1 squared is 1, so this is 1 pi. Area of the inside circle is 1 pi. And I want us to know that from here to here is a distance of 4. This entire thing is 4, not just this portion for this particular problem. I should have marked that somehow for you. So this entire circle has a radius of 4. So pi times 4 squared would be pi times 16, or 16 pi. Pi's cancel. Take 1 divided by 16. We turn it into a percentage by moving the decimal 2 places to the right and rounding to the nearest tenth of a percent. So this is 6.3%. Moving on to number 7, working with semicircles. Semicircle is half of a circle. From here to here is a distance of 6. That means the semicircle has a radius of 3. Notice that the outside is shaded, so we're going to do large subtract small divided by large. So this large region, if we think of it just as a circle, well, as a circle, again, it's pi r squared. So pi times 3 squared, or also as 9 pi. But it's a semicircle, so it's only half of that large circle. So I'm going to do 9 pi over 2. That represents the area of the large region. Subtract the small circle. 2 times 2 is 4. Over the large. 9 pi divided by 2. We're going to plug this into the calculator together. Beginning parenthesis, 9 pi divided by 2. Subtract 4, get an answer, and divide by 9 pi divided by 2. Make sure to use your parentheses. And now we're going to round this to the nearest tenth upper percent. That makes this 71.7%. And the last guided practice problem. Just like number 7, from here to here is a distance of 8. That gives us a radius of the semicircle being 4. The outside is shaded, so large subtract small divided by large. Your large circle is pi r squared, or pi 4 squared. So pi 4 squared is 16 pi. But we only have a semicircle, half of a circle, so it's 16 pi divided by 2. You could also write 8 pi. Subtract this inside region, or smaller region. 3 times 3 is 9. Again, divided by 16 pi divided by 2. And again, feel free to write 8 pi to make it easier. So 8 pi subtract 9, get the answer, and divide it by 8 pi. 8 pi subtract 9, and then divided by, in parentheses, 8 pi. 64.2%.